Today we are going to discuss the topic nuclear physics of O level. In this topic, first of all, we will discuss the atom. In core subject, we are going to describe the structure of atom in terms of positively charged nucleus and negatively charged electrons in orbit around the nucleus. Number two, know how atom may form positive ion by losing electron or form negative ion by gaining electron. The supplement topic is describe how the scattering of alpha particles by a sheet of thin metal support the nuclear model of the atom, which provide the evidence for a small nucleus surrounded by mostly empty space, a nucleus containing most of the mass of the atom, a nucleus that is positively charged. So let's start with our first topic, the structure of atom in terms of a positively charged nucleus. An atom consists of positively charged nucleus. The nucleus is present at the center of the atom and it consists of nucleons, and these nucleons are combined called as nucleons, but separately we call them positive protons and neutral neutrons. The proton contain positive charge. The charge on proton is positive and the charge on neutron is neutral. It means it cannot be affected by any electric field. Neutrons cannot be affected by any electric field. That's why these are called neutral particles. Okay, the third thing that an atom contains is electron. Electrons are negative charged particles. Which orbit the nucleus. Orbit the nucleus means there are orbits around the nucleus in which these electrons revolve around the nucleus. And the radius of the nucleus is lot smaller than the radius of the entire atom. An atom radius is 10 raised to power minus 10 meter. Atom radius is 10 raised to power minus 10 meter, while nucleus radius is 10 raised to power minus 15 meter. It is 10 raised to power minus 5 times less than that of the atom. Almost all the mass of the atom lies in the nucleus. Why we said that almost all the mass of the atom lies in the nucleus, we will discuss in the next topic. Okay, here is the structure of atom in which the positive particles, those are protons. The neutral particles, those are neutrons, are present at the center of the atom, which is called as the nucleus of atom. While electrons revolve in circular orbits around the nucleus. Okay, here are some very important points. A neutral atom has same number of proton and electron. Because the charge of proton is +1 and the charge of electron is -1. So if they have same number of proton and electron, they will cancel the charge of each other and atom will be neutral. Okay, as I said that most of the mass occupied by the atom is at the center because the mass of proton and neutron is almost equal, which is 1 and 1, while mass of electron is considered as 0 because it is much smaller than proton and neutron. It is equal to 0.0005 according to this one. Okay, almost equal. Why we said it is almost equal? Because when a neutron decay, it convert into proton plus electron. It means the mass of electron and proton is equal to that of neutron. So neutron and proton are almost equal, not equal but almost equal, so we are considering here that they are almost equal. So when we write it in our topics, we will consider them equal. Okay, here are the questions related to our topics. An atom consists of a nucleus made up of proton and neutron surrounded by orbiting electrons. Which of these particles has positive charge? So what are the particles? Protons, neutrons and electrons, orbiting electrons. Okay. Which have positive charge? We know that proton has positive charge. Which of these two particles have almost equal mass? So we have studied that proton and neutron have almost equal mass. Proton and neutron has almost equal mass, and proton is positively charged and electron is negatively charged. Okay, question number 2. A neutral atom consists of electrons orbiting a nucleus. The nucleus contains proton and neutron. Which statement about the atom must be correct? The number of electron is equal to number of neutron. So that not always not true. There are some time when neutrons are greater in number than electron. The number of electron is equal to the number of proton. Okay, this statement is correct statement. This statement about the atom must be correct because we are considering a neutral atom. A neutral atom has equal number of proton and equal number of electron. Okay, the third one, let's check the third one. The number of neutrons is equal to number of proton. This is also not correct. There could be a difference between the number of protons and neutrons as well. The number of electron, neutron and proton are all different. It is also wrong because in neutral atom the number of proton must be equal to the number of electron. So B is the right option. Okay, the question number 3. A proton and a neutron are each close to positive nucleus. The center one is the positive nucleus and we have a neutron and a proton on both sides of the positive nucleus. How does the charge on the nucleus affect the proton and neutron, if at all? Okay, we know that positive and positive charge or negative charge, they repel each other, while positive and negative charge they attract each other, which is called as unlike charges attract while like charges repel. So the neutron is attracted, the proton is repelled. This statement is correct. The proton is repelled is the right statement. But neutron could not be attracted by a positive nucleus because a positive nucleus attract a negative electron, not the neutron, because neutron has no charge. So this statement is wrong. The neutron is not affected, the proton is repelled. So B option is also right over here also. In the previous question we have seen that B is the right option. Here is also B is the right option. The proton is attracted, which is wrong. The proton is not affected, which is also wrong because positive and positive repel each other. Okay, the question number 4. Which diagram could represent the structure of a neutral atom? Again, we are discussing the neutral atom. In neutral atom, what is the statement about the neutral atom? It has equal number of proton and electrons. Equal number of proton and electron. It has equal number of proton and electron. So proton is represented by plus circle, electron is represented by negative circle. So here are 2 electrons and 3 protons. So these are not equal. 1 electron, 2 proton, not equal. 2 electron and 2 proton. This is the right option. B is your right option. And the first one, 2 electron, 1 proton, which is also not equal. Okay, the question number 5. An atom of an element lithium has a nucleus number of 7. Sorry, nucleus number is nucleon number. What is the meaning of nucleon number? Nucleon number mean number of proton plus number of neutron. Number of proton plus number of neutron is called nucleon number. And the proton number is 3. It has 3 proton. It has 3 proton. So it has 3 proton, which means how many neutrons are there? Proton is equal to 3. Neutron is equal to 4. How we can? 4 plus 3 equal to nucleon number 7. Which diagram represent the neutral atom? In neutral atom, we have equal number of proton and equal number of electrons. So electron must be equal to 3. Okay, the first one contain 2 electron, wrong option. The second one contain 3 electron, but there are not 7 nucleons. So it is wrong. This one contain 3 electron, 1, 2, 3, 4. 4 neutron, 1, and here are these two are also proton. These two are also protons over here. So C is your right option. In D, there are 1, 2, 3, 4, 5, 6, 7. 7 electron, which is the wrong option. Okay, number 2 topic. The second topic of this chapter. Know how atom may form positive ion by losing electron or form negative ion by gaining electron. How ions are formed? We have discussed it in chemistry as well. Ions form when atom lose or gain electron to obtain a full outer shell. Full outer shell means electronic configuration of the nearest noble gas. Atom lose electron or atom gain electron. Metal mostly lose electron, while gas non-metal mostly gain electron. Okay, metal atom lose electron to form positive charge ion. When an atom lose electron, the number of proton increases. The number of proton increases. It's not like increases like something add up. It is like in neutral atom there are equal number of proton and equal number of electron. But as the electron number decreases, the proton number increases. Proton number increase. Increase mean like we have 3 proton and 3 electron. 1 electron goes. So we have now 3 proton and 2 electron. So we have 1 extra positive charge. That's why we called it a positively charged ion. Positively charged ion. If it loses 1 electron, it is 1 positive. It loses 2 electron, it becomes 2 positive. Similarly, when an atom gain an extra electron, it become negatively charged ion. It become negatively charged ion because at that time an electron number increases. So proton are less than the electron. So if proton are less than electron, so electron number increases, so charge of minus increases. Okay, very important topic about the scattering of alpha particles by a thin metal sheet. This experiment is done by Rutherford. In Rutherford experiment, he aimed alpha particles. This is also known as J.J. Thomson. Whose name is J.J. Thomson, and his model of atom is known as plum pudding model. According to him, that an atom consists of a cloud of positive charge with negatively charged electron dotted around inside it. Okay, first of all, alpha particle. What is alpha particle? Alpha particle is helium nuclei. Helium helium nuclei. What is helium nuclei? Helium nuclei contain 4 nucleons and 2 protons. 2 proton and 2 neutrons. 2 protons plus 2 neutrons. This is called helium nuclei or alpha particle, and alpha particle contain 0 electron. An alpha particle is helium nuclei. Why we call that helium nuclei? Because it is positively charged, because it only contain protons. Its electrons are ionized. Ionized means he loses 2 electrons. He loses 2 electrons. That's why it is just containing 2 proton and 2 neutron. When these alpha particles, which is also known as helium nuclei, are bombarded on a thin gold foil, what happened? First I will show you some figure, then we will come back to the explanation. Okay, these alpha particles, some of these alpha particles mostly passed straight. Most of these alpha particles pass straight through the foil. Some are deflected at many angles. Some are deflected at some angles. Some are reflected back. So, what are the conclusions from this? We concluded that the atom was composed primarily of empty space. Very important point. Because most alpha particles pass straight through. As most of the alpha particles pass straight through, we said that the atom mostly space is empty. Mostly space of atom is empty. Next one. It has a nucleus which was massive and contained most of the atom mass. The most of the mass is at the center of the atom, and we named it as nucleus because alpha particles deflected straight back. As shown in this figure over here. The alpha particle coming toward the nucleus deflected straight back. The third one. The nucleus was positively charged because it repelled the positive charge alpha particles. We know that positive and positive repel each other. That's why they are deflected at some angles. Alpha particles are deflected at some angle. So what are the conclusions? We are going to discuss it again. The atom was composed primarily of empty space because most alpha particles pass straight through. Second one, it has a nucleus which was massive and contain most of the mass of the atom because it deflects some alpha particles straight back. It is massive, that's why they are deflected straight back. They do not pass through it. The nucleus was positively charged because it repelled the positively charged alpha particle. Alpha particles are repelled from the positively charged nucleus. Okay, question number 1. Which statement about the nuclei of all atoms is correct? They are very small compared with the size of the atom. This is the correct one. They always contain the same number of proton and neutron. This is wrong. We have discussed there could be difference between the number of proton and neutron. They contain electrons. Sorry, electrons are not present in the nucleus. They have a total charge of 0. Sorry, the nuclei have total positive charge. The first statement is the correct statement, which is that they are very small compared with the size of the atom. Number 2. A very important experiment increased scientists' understanding of the structure of matter. In the experiment, particles scattered as they passed through a thin metal foil. Which particle were used and to which conclusion did the experiment lead? Okay, we have discussed that alpha particles are used. So first two options could be the right one. Beta particles are not used. What are beta particles? We will discuss it in the next chapter. Okay, what are alpha particles? Alpha particles are helium nuclei and this is used in studying the structure of atom. Okay, matter is made up of atom. Atom have a very small nucleus. What are the conclusion of that? We know this conclusion is drawn way beyond this experiment that atom is made up of any matter is made up of atom. Okay, what conclusion we have drawn from this? Atom have a very small nucleus. So B is the right option that we have used alpha particles and the conclusions are atom have a very small nucleus. Okay, which diagram represent an experiment that provide evidence for the nuclear atom? So we have used alpha particles. So this and this one is the wrong option because we haven't discussed about the beta particles. Okay, the alpha particle when go toward the gold nucleus, they bend it away from it because gold nucleus is positively charged and alpha particles is also positive charge. So C is the right option because they are deflected away from it, not deflected toward it because of like charges repel each other. The scattering of alpha particle by a thin metal foil spoiled a nuclear model of an atom. Why are alpha particles used rather than neutrons? Because they always travel more slowly. No, this is the wrong option. Because they are heavier. No. Because they are large in diameter. No. Because they have a positive charge. We have used positive charge because positive charge repel positive charge. Positive charge attract negative charge. If we use neutron, neutron will not be affected by anything because neutrons are neutral. So it will not define as the charge of the atom. Okay, in Geiger and Marsden's alpha particle scattering experiment, alpha particles were directed at a very thin gold foil. Figure 11.1 show 5 of the nuclei of the atoms in one layer in the gold foil. This is your gold foil of which 5 different nuclei are shown. Also shows as the path of the 3 alpha particles directed toward the foil. 3 alpha particles are coming toward this foil. Okay, on figure 11.1, complete the path of these 3 alpha particles with very important question. The one moving toward the toward the nucleus but not toward the center of the nucleus will be deflected. Will be deflected. The one passing between the nucleus will go straight. The one moving toward the nucleus will go back. This is the shape you have to draw. The one going toward the close to the nucleus will deflect. The one going away from the nucleus will pass straight through. The one going toward the nucleus, toward the center of the nucleus will reflect back. Okay, the question number 5, same question. State the result of the experiment that showed that an atom consists of a very tiny charge core containing almost all the mass of the atom. State the result of the experiment which some of the alpha particles deflected straight back. Some of the alpha particles deflected straight back. It showed that almost all the mass of the atom is present at the charge very small tiny charge core. That's why alpha particle deflected straight back. State the sign of the charge on this core. The core is positively charged. The core means the center of the atom. The center of atom contains nucleus. Nucleus consists of neutrons and protons. Neutrons are neutrals and proton contain positive charge. So the charge on the core as a whole is positive charge. State what occupies the space between these charge cores. This is mostly empty. Mostly empty. You can also write electrons. Electrons are also present between them. Okay. Question number 6. In an experiment, alpha particles are allowed to strike a thin gold foil in a vacuum. Almost all the alpha particles pass straight through the gold undeflected. Only a very small number of alpha particles are deflected from their original path. This result reveals certain feature about the atom of the gold. State what is shown by the fact. Most alpha particles pass straight through the gold undeflected. It means most of the atom is empty. Most of the atom is empty. Some alpha particles are deflected back the way they came. A massive core or nucleus present at the center of atom. Okay, alpha particles are deflected back the way they came because a massive nucleus present at the center of atom containing proton and neutrons. Okay, the question number 7, figure 11.1 show the path of three of the alpha particles A, B and C traveling toward the foil. Alpha particle A is traveling along a line which does not pass very close to a gold nucleus. Alpha particle B is traveling along the line which passes close to the gold nucleus. Alpha particle C is traveling directly toward a gold nucleus. Okay, explain why an alpha particle and a gold nucleus repel each other. Because both are positive charged. Both are positively charged. Okay, question number 2, part B, on figure 11.1, draw lines which with arrows to show the continuation of the path of the alpha particles A, B and C. Okay, A. In A, traveling along a line which does not pass very close to the gold nucleus. It does not pass close to the gold nucleus, so it will pass straight through. Alpha particle B is traveling along the line which passes close to the gold nucleus, so it will be deflected. It will be deflected. Number 3, alpha particle C is traveling directly toward the nucleus, so it is directly toward the nucleus, so it will bend back. It will be bended back. State 2 conclusion about the gold nucleus from the experiment. Most of the atom is empty. There is massive nucleus present at the center of atom. containing proton and neutron. Okay. Alpha particles can be scattered by a thin gold foil. Figure 11.1 shows part of the path of the 3 alpha particles. Complete the path of 3 alpha particle. The one away from the gold nucleus pass straight through. The one close to the gold nucleus bend away. The one going to at the center of the atom will reflect back. Why does the scattering of alpha particle show about atomic structure? The most of the same answer. Most of the atom is empty. Nucleus present at center of atom containing proton and neutrons. Okay. State the nucleon number, mass number of alpha particle. Okay, mass number we have discussed that it contain 2 protons plus 2 neutron. So the nucleon number, which is also known as mass number, is 2 plus 2 equal to 4. We will discuss in detail about the nucleon number, proton number, mass number. Okay. So we have discussed nuclear physics, the topic, the atom today. We will discuss next topic tomorrow, inshallah.